Okay, so today we are going to talk about this topic, this reaction called aldol condensation reaction. So in this reaction, basically like all other organic reaction, there is a requirement of a reactant, and then with the help of a reagent, a specific reagent, we will get a product. Now in case of aldol condensation reaction, the reactant is basically a carbonyl compound. So it could be an aldehyde or a ketone. So we will take a general aldehyde molecule. Let's take this molecule uh, CH2, then C double bond OH. So this is a aldehyde. Now the reagent that will be required for this reaction will be dilute alkali base, that is dilute NaOH, and the final product that we will get is this. OH. I'll explain this product RH and then C double bond OH. So no need to worry. I will explain the product. Now we have started with this aldehyde, and the most important thing in this reaction is that there is a requirement in the reactant. So this carbon is the carbonyl carbon. So the adjacent to this carbon, this CH2 carbon is basically the alpha carbon. And we can see there are two alpha hydrogen. So alpha hydrogen is required for aldol reaction to happen. Now let's talk about the product. Here this is the carbonyl carbon, the adjacent carbon is the alpha carbon, and adjacent to alpha carbon there is this beta carbon. Now you can see that in beta carbon there is this OH group. So the product that we are getting in the aldol condensation is basically beta hydroxy aldehyde. Okay, now the thing is, as there is this aldehyde group, dehyde, and also alcohol, that is this hydroxy group. So the ALD from here, aldehyde, and OL from alcohol, this sums up to give you the trivial name aldol. Now, as I told that alpha hydrogen is required. Without alpha hydrogen, aldol condensation will not happen. So that we are going to discuss in the next phase, that is the mechanism part of this reaction. Okay. Now the mechanism, there are three steps. The first step of the mechanism is deprotonation to form enolate. Okay. Now let's take a simple aldehyde. Let's take CH3C double bond OH. Okay. Now whenever you are giving this OH minus, this OH minus first will do what? It will take up one of the proton from here, like this. It will capture one of the proton and there will be an anion. Now this will form this H H CH2 minus and C double bond OH. Now this carbanion is highly stable because it can conjugate with the adjacent carbonyl group that we know, and it can form this enolate ion. Okay, so this is the enolate ion. So this is the first step when the enolate ion will form. Okay, then in the next step of aldol condensation is addition or nucleophilic attack. Okay, so the enolate ion that forms, that attacks another aldehyde. Now in this case, as you can understand, is that this is the nucleophile and the carbonyl compound, that is the aldehyde, is the electrophile. Okay, so what will happen here? This negative charge will fall and this bond will attack here at the carbonyl center, because the carbonyl carbon is the electrophilic center of this electrophile. Okay, and then finally what we will get is that something like O minus, this and then double bond OH. So this alkoxide ion will form. Okay, and in the third step and in the final step is the protonation step. So in the first step is the deprotonation and final step is the protonation one. So what will happen here? This molecule will capture hydrogen from water. So what will happen? This molecule here, O minus, will capture, this anion will capture one proton from water and will form hydroxyl anion. Plus OH minus. Now this is our product, the beta hydroxy aldehyde. But you need to remember one thing. You can see that OH minus that we used as a reagent is getting generated at the end of the reaction. That means this base is basically acting as a catalyst during the course of the reaction, because at the end of the reaction it is getting regenerated. Okay, so catalytic amount of base will convert this aldehyde to beta hydroxy aldehyde or the aldol product. Okay, now let's discuss further. Sometimes if you are using some vigorous approach. What do I mean by vigorous approach? It could be heating condition or high concentration of base or stronger base In those cases, what will happen? The aldol product will not be the end product of aldol reaction. What will happen? This will get converted to form this alpha beta unsaturated aldehyde. You can see this is alpha and this is beta and there is a double bond, so it is a alpha beta unsaturated aldehyde. Okay, but this will only happen if I am using this vigorous approach, that means heating or high concentration of base, etc. So let's see how this conversion is happening mechanistically. Okay, so what happens in this case? Whenever you are giving, let's say, heat, what is happening? The OH minus will capture another equivalent of another hydrogen, enolate hydrogen or alpha hydrogen. Okay, and that will lead to another enolate anion like this. Here will be a negative charge and then double bond OH. Okay, and this can be in the resonating form of enolate like this. Okay, now let's discuss briefly about a specific type of elimination reaction, that is E1CB elimination. Okay, what happens in case of E1CB elimination is that, let's say there is H and there is leaving group. So what happens in this, in case of E1CB, initially in the presence of base there is a formation of anion, carbon ion. Okay, and after that this carbon ion leads to the elimination of the leaving group and then double bond formation takes place. So same thing happens in this case also. So this if this is the acidic proton, then this is the conjugate base. Okay, that's why the name comes like E1CB. CB means conjugate base. So here also initially there is a anion formation which is taking place. Now, will this anion lead to the formation of the double bond? Let's see. See, this enolate ion, what will it do? This will fall here, this will fall here, and then this OH will leave. And finally, the product that you will get is this alpha beta unsaturated double bond. So, as you can see, this elimination here is uh, happening through the anion formation. So, we can conclude that uh, in the vigorous approach, there is a elimination reaction happening, and that elimination reaction is happening through E1CB mechanism. Okay.